Hello everyone. In this video, we are going to discuss about the operating states of power system. Operating states of power system. We have 5 classifications on operating states. First one is the normal state or the stable one, and the second one is alert state, and the third one is emergency state, and the fourth one is in extremis state. Okay, and the last one is restorative state. These states are interconnected. Okay, and the normal state and the alert state dual-way communication, where the alert and the emergency state are two-way communications, and the emergency state to inextremate state is a one-way one, and from inextremate state to the restorative is the one-way, and from the restorative state to the alert state is possible, and from the restorative to the normal state is possible. And we are going to discuss in detail about how these directions matters in each cases. First one is the normal state or the normal operating, the actual operating state where the system is in a stable condition, where the equality constraints and the inequality constraints. Okay, to know about the equality and inequality constraints, please click the link mentioned here. Okay, we can mark equality constraint as E and inequality constraint as I. Okay, and the equality constraints and the inequality constraints in general, if you want to mention what are equality and inequality constraints are the power balance equations, whereas the inequality constraints are the operating parameters such as voltage, generation limits, or the current limits, or the transformer rating limits comes under inequality constraints. In the normal state, both the equality and inequality constraints are satisfied. Okay, we can mark it as E and I, both are satisfied, and the generation, whatever the generation we are having, is sufficient to supply the demand. There is no excess generation needed in this state. Okay, and there hasn't been any overloading on the generators also in the normal state. We do have a sufficient reserve margins for the security and for the normal operation of the state. That is what the normal state is all about. Then comes the alert state, or we can before moving to alert state, we can mark this normal state, the line above, whatever the state here, we can mark it as the secure one or the secure state. Again, if we want to classify, we can mark this as a secure state above one normal state. And moving on to the alert state, here also both the equality and inequality constraints are satisfied, E and I are satisfied. Okay, however, but the reserve margins are reduced now because of some increase in the demand or the unexpected loading conditions. The generators are being overloaded, or the reserve margins are being reduced in this case. And there is some possibility that inequality constraints, like the limits on the generator, as we mentioned, the generators are being little bit overloaded. Okay, not to the maximum extent, but to the little bit. So in this case, the inequality constraints, as we mentioned, the limits on the generators may be violated because of the disturbance. Okay, now the preventive control measures are being taken here, which will lead the alert state back to the normal state. So we can mention the alert state as a preventive control state. Okay, so that this from this state, if we can take some preventive control measures, we can move from alert state back to the normal state. Okay, and then comes the emergency state, where the equality constraints are not affected, but the inequality constraints are being affected. We can mark it as I dash, where the inequality constraints are not satisfied. Okay, where in this case, since we are mentioning it as an sorry, here we can mention it as emergency state. Due to the disturbance occurred in the system may enter from alert state to the emergency state because of the overloading on the generators or the voltage limits, or maybe the current limits or the transformer limits. Now the state from alert to emergency state has been initiated. Okay, because of the imbalance between the generation and the load, there has been overloading been happening. And these measures, we can also call it as emergency control measures are being taken, where in emergency control measures we can say direct or indirect load shedding is being happening, or maybe the generators are being shutting down, or the capacitor banks, or we can say the reactor switchings are being taken places, or the network splitting of the networks are being happening in this emergency state. Okay, if these measures are not taken, like what we mentioned, the direct or indirect load shifting or load shedding, or the generator shedding, if it is not being taken care of, or the emergency control measures are not being taken care of, this may lead to in extreme state. Okay, so eventually if we take these measures, so from emergency state we can move back to the alert state, taking these control measures. Okay, so we can state emergency state as emergency control measures, or the simply control measures. We can mark emergency state as emergency control measure. Now next comes the inextremate state, where both the equality and the inequality constraints are not being satisfied, which means the power balance is also not there, even the control parameters or the operating parameters are not being taken care of. In this state, both the equality and inequality constraints are violated. Okay, and this violation of the equality constraints implies the generation and the load are not in balance, or the load is more, or the generators are failing to supply the load, and this leads to inequality constraints being violated, and this will lead to the islanding cases. Some part of the system load is already being lost, which is the major concern for power system engineers to be taken care of. And here the emergency measures must be taken care to prevent the total grid collapse, and the major grid collapse being happening at this state of the system. We need to take care of the protective equipments in the grid. We need to maintain the or to minimize the losses. In this case, we need to take care of the transformer, the transmission line overloading conditions. Everything needs to be taken care in the in extremis state. Okay, and last comes the restorative state, where the equality constraints are being violated and the inequality constraints are being taken care of, where from the extreme in extreme state we are restoring the system, where the generators now not being loaded. Okay, we are only taking care of the limits on the generators, we are only taking care of the voltage limits on the transmission line, we are taking care of the current limits or the transformer limits on the system, and the generators are not being loaded actually, or the power balance has not been restored here. Okay, and the equality constraints discuss about the power balance constraints between the generator and the load. Here in the restorative state we are not in up to 100% of the load supply at this state. We are trying to regain the system back to the normal state, from here to the alert state or back to the normal state. And here we are synchronizing the system so that the system works 100% effectively from here onwards. Okay. These are all about the operating states of the power system. Here, when we discussed about the normal state, we mentioned it as a secure state, and we have two more lines to discuss. Here comes the restorative state or the alert state, and this is insecure one. This is an insecure state, and here the in-extremis state or the emergency state, we can say security has been lost at this state. This is an insecure where we can make the system back to the secure state, where in security lost state the system has already been disturbed, and we need to gain control over the system, not to make sure that the system is not going back to the grid collapse condition or the islanding cases. Okay. These are all the operating states of the power system. If you people have any doubts, please do comment below. Thank you.